Thank you for joining this training for HVAC contractors on the Vermont 2020 Commercial and Residential Building Energy Standards. This training is provided by Efficiency Vermont on behalf of the Energy Code Assistance Center. My name is Tori Scarzello, and I'm a program manager for Efficiency Vermont. And this morning's presenters are Charlie Carpenter and Matt Sargent, who are both on our team of energy consultants at Efficiency Vermont. So just a couple of housekeeping items before we begin. This webinar is worth 5 EEN credits. So if you're watching this training as a recording, we'll be sure to share some information on how to make sure that you've received credit for watching this training. And this training is being recorded, as I mentioned, and will be available on the Efficiency Vermont website for future reference. So I'll share a link to where you can find this training as well as future code trainings. So with that, I'll hand it over to our presenters, Matt and Charlie.
Hello, everybody. Thanks for joining us today. I think as we go forward, I'm just going to turn my camera off so we can focus on the presentation, on the materials, the graphic materials. So turning my camera off. Nice to see you all.
I'll do the same. My name's Charlie Carpenter. I think Matt's gonna kick us off.
All right, well, let's get started. Welcome to today's training. I think what we're going to do is Charlie and I are going to do a little bit of a tag team approach here. I'll talk about the slides that have to do with the residential code, and Charlie will discuss the slides having to do with commercial code updates for 2020. I do want to say that this training will cover most, but not all, of the HVAC of the full code. It's not a full code training. It's what we've done is we've taken the parts that pertain to HVAC contractors, and we're going to present like things you need to know about the new code. Full language for the RB's code is here. You can click this link. You can call the Energy Code Assistance Center at any time if you have problems or questions about the code. And I do just want to say that there is a recorded training, and there's another live webinar training coming up on August 5th. So be sure to take a look at that if you have questions about the full code. And the Department of Public Service also has a couple of recorded trainings on RB's and CB's upgrades for 2020, and they're located at this location, this link here. Other trainings are going to be posted on the webpage, and they are going to be publishing handbooks. They should be being published at this moment. When they'll be available is still unknown to me, but we're hoping very soon. That's on both RB's and CB's. So the effective dates for both codes, both the residential and commercial code updates, is September 1, 2020. So any projects that are breaking ground after September 1, 2020 will need to qualify with the new code. Projects that have already started will still follow the 2015 codes. That makes sense to everybody.
On the commercial side, projects need to obtain a building permit before September 1st, 2020, and they can still follow the 2015 commercial energy code after
okay,
September
there's a good
1st.
Between the way
yes.
the way they're counting work starting. So with residential, it's actually starting the groundwork. For commercial, it's getting the permit.
Correct.
So obtained or applied for. Is that right, Charlie?
Correct. Yep. And a building permit, it could be just a standard building permit or Act 250 permit. So the September 1st deadline is the cutoff point for the commercial code, whether you're on the current 2015 energy code or the updated 2020 energy code.
Got it. Okay, that's pretty clear. So for mixed use buildings, a mixed use building 3 stories or less in height, residential building requirements are in effect in the living spaces, which include the the actual living units themselves, plus hallways, laundry, community rooms, foyers, etc. And the commercial code, CBs, serves areas served by both residential and commercial uses. And any buildings 4 stories or more in height, CBs applies to the whole building, all areas. That's pretty straightforward. So both codes are laid out fairly similar. So they have these 6 chapters. In chapter 1 deals with what buildings need to comply and how. Chapter 2 is definitions, general requirements, and 3. Chapter 4 is where they get into the details about the energy efficiency requirements for the codes. Chapter 5 deals with renovations and alterations and change of use in existing buildings. And chapter 6 is just a list of referenced standards. Same format for both codes. Okay, so there are here are the 2020 compliance methods, and for RBs, there is a track for prescriptive tables plus points. I'll get into that a little bit later, what that means, but basically you have to pick a prescriptive package from the tables, and then you have to do additional points. Also a ResCheck software compliance method and a home energy rating compliance method. If you're doing the home energy rating method, there are mandatory requirements you need to follow, and they're referenced in section 406.2. You need to get a HERS score or ERI of 61 or less, and 5 of those points can be from a renewable energy system. Charlie, do you want to go through the CB's compliance methods?
Sure. So for the upcoming 2020 CBs, there are 2 compliance methods, sort of similar to RBs. The first is just following all the prescriptive requirements that will be outlaid in the code book, and you would use the ComCheck software to show your compliance with that. That's the most common way that people show that they've met the code. The other way to do it is to take standard ASHRAE 90.1 version 2016 and then add in some of the applicable provisions that are listed out in sections C401.2.1 of the code, and also the applicable requirements of section C406, which are some additional efficiency requirements that are applicable to any new building. So those are the two methods you could use.
Okay, so in RB's chapter 1, buildings that must comply: single family, 2-family, multifamily, residential, 3 stories or less, and the residential portion of mixed use building. So those, if you're building one of those buildings, you have to comply with RB's 2020. There are some exclusions. So there's this like super low energy use, and I don't know if anybody can put this into context. Less than 3.4 BTUs per hour per square foot is crazy low. Don't plan on that. There are exclusions for unconditioned buildings. Mobile homes without basements have to meet a different standard. Also excluded are summer camps, yurts, hunting camps, basically buildings without heating systems. And these buildings can have a wood stove or apparently an on-site renewable heating system. So there's documentation requirements, and this is in municipalities where inspections or document review is done by authorities having jurisdiction. Documents are reviewed for code compliance. They're approved and stamped and kept with the construction records. And where authorities having jurisdiction provide inspections, so plumbing, rough-in, mechanical rough-in inspections are conducted, and installation is verified as being compliant with the code requirements and documents. So yeah, once you get your documents approved by the local authority, if you have a local authority approving documents, then your permits are good to go, and you just have to build according to your documents. That's chapter 1 for RBs. Chapter 2 is definitions, and I believe this is in RBs and in CBs. Chapter 2 is so here's an example of some of the definitions on the right. So if you ever wonder what the code definition of a warm air furnace is, just go look it up in chapter 2. Want to take this one, Charlie?
Sure. So a new definition for CBs that they put in that is going to be quite applicable to this code is cold climate heat pump. And this is a list of what must be required for a piece of equipment to be considered cold climate heat pump. It needs to be air sourced, have a variable capacity inverter driven compressor. It's got to be able to provide full heating output at 5 degrees Fahrenheit outdoor air temperature, and at that temperature it also needs to have a minimum coefficient of performance of 1.75, and that rating needs to be matched with a specific indoor. The outdoor unit and indoor units need to be matched and rated through AHRI, so that you can't be mixing and matching units. They need to be rated together. Go ahead.
It's the exact same definition in RBs.
Okay.
And Charlie, do you know if this is the same definition that NEEP uses to define a cold climate heat pump on their list?
I am not positive, but I would assume it is very similar, if not identical.
Yeah, I think it's the same.
I think they changed the definition to match that more closely. And this is another new definition, on-site renewable energy. So that's energy generation that needs to be located on the project site itself. And these are the different ways that you can obtain that renewable energy through solar radiation, wind, waves, tides, landfill gas, biogas, biomass, or the Earth's own internal heat.
This must come from the international code, because I think doing tidal energy on site in Vermont is going to be tricky.
Same with waves. Yes, this is probably language from the IECC. And I do want to state that I think for both Matt and I, the information that we're providing today is not final language from the codes. It is from the approved language that passed through the state legislature back in December. So this is, everything here should be, for the most part, what will be in the final codes, but when the final language comes out, we will be going back and double checking on everything.
Right, we did mention that those final codes are currently in publication now, so those should be available very soon. But until then, we're trying to get the word out on the adopted code language, which is what we have to go with.
Yep.
So there are general requirements in Chapter 3, and the ones that pertain to HVAC would be Section 3.02, where they discuss design conditions for calculating heating and cooling loads. Section 304, where they discuss design criteria for ventilating systems. And then there's combustion safety, which is discussed in 305. So Chapter 3 has a lot more than this in it, but this is the stuff that's going to pertain to HVAC. Here's the RB's climate design parameters. So this is a table. I've copied the table from, you can even see the draft watermark on the back of it. I've copied the table from the adopted code language. Here are your winter design dry bulb and summer design dry bulb and wet bulb. Here are your heating and cooling degree days and the interior design conditions. There are some exceptions and alterations to these, and that's noted in 3.02. I think one of them is altitude, and that's why we have this altitude chart in here.
So for The CBs, it's a lot of the same design parameters. It's stating the entire state of Vermont is in climate zone 6A. The heating design condition has been changed. It's slightly warmer than it was in the previous version, or the RBs, which is minus 11 degrees Fahrenheit. It's been warmed up to -9 for the commercial buildings, and similar cooling, dry bulb and wet bulb design temperatures. I don't have them listed, but the heating and cooling degree days are both very slight amount lower for the 2020 CBs than 2015, and same indoor design temperature ratings for load calcs as the previous code and RBs, 72 for heating and 75 for cooling.
So the basic requirements in RBs are listed in chapter 3, and here they are. And I think the interesting thing about this list is how much of it pertains to HVAC. So of the 16 points that they have here, several of them, the majority of them have to do with mechanical systems, plus there's basic requirements for building envelope measures. So when you look at the summary of them, they give you more information here. So for example, the basic requirements that all homes will need to comply with are no ducts, air handlers, or filter boxes allowed in unconditioned space. So we need to read these through carefully, and I'm not going to read them all, but they are listed here in this presentation as a reference for you if you want to check into them a little deeper. So yeah, it's there's a lot of other stuff to know. So this is what applies to every building, no matter what compliance method you're using. And more general requirements. Section R302 is about calculating design conditions for calculating loads. So we're using ASHRAE 97% winter values and 2% summer values. Here are the exceptions that I mentioned earlier. Winter heating design temp, if you're located above 1500 degrees, you can use a different design temp. If you're located in Caledonia, Essex, or Orleans counties, you can use a different winter heating design temp. If the National Climate Data Center provides different climate design than we're using, you can get an exception for that. Or if the local officials agree, you can change the winter heating design temp.
I believe these are the same exceptions for the commercial code as well, based on altitude and the county of Vermont that you're designing the building in.
This National Climate Data Center, if you have a particularly interesting microclimate where you are, you can use this website to prove that there are different climatic conditions, and you can get approval based on that. So again, here's design criteria for ventilation systems. Table 304.2 here talks about what we call spot ventilation or local exhaust ventilation. So this is the same in a bathroom. You would, with a tub or shower, you need to have 50 CFM intermittent or 20 CFM continuous. So we consider continuous if you have an HRV or an ERV pulling exhaust air out of that bathroom, it needs to be 20 CFM. Or you can, you must comply with, for whole house ventilation, you must comply with either the RB's ventilation standard, which is outlined in 304.2 through 304.11, or the ASHRAE standard 62.2 2016, and there is a link there to a calculator that can calculate that value for you. Building Science Corporation Standard 01 2015, and then there's a a link to the building science website that talks about that standard, or the passive house ventilation requirements. So basically for whole house ventilation requirements, you have 4 standards that you can choose from. Pick one based on the building that you're doing and what makes sense for you. Those are new. The Building Science Corp standard is new. The passive house ventilation requirement standard is a new addition to the 2020 code. So here's the RB's ventilation standards. And this is the prescriptive fan capacity requirement. So this is based on the manufacturer's rated capacity for the fans, based on number of bedrooms and house size. So homes that get over 3,000 square feet have a different requirement based on size. Very straightforward. There's a testing option, 15 CFM outdoor air per bedroom plus 15 CFM during occupancy. These requirements listed in this table are the same as from the 2015 code, so nothing's changed here. Here we go again. Still, the stuff's not new for design criteria and ventilation systems. There's testing options. There's performance verification. For testing options, you must measure based on 304.6.1. They give you what they're looking for, how we measure them. We need to ventilate only during occupancy. There's criteria for controls. There's criteria for intermittent operation and continuous operation. There's criteria for where the on-off switch goes. There's criteria for installation requirements on the ducts, which concerns intake locations, how the ducting should be done, etc. So be familiar with all of these aspects of the code. RB's 304 spells it all out for you, how to do ventilation systems. So RB's 304, this is also present in the 2015 code. We need makeup air for range hoods in excess of 400 CFM. And I will just say that this makeup air adds expense, and there's considerable energy penalty for introducing, I don't know, 400 to 1200 CFM of outdoor air every time the range hood is operated. These makeup air systems have to be interlocked with the range hood, and they need to have a means of closure. So here is the efficacy for any fan doing ventilation according to RB's. There is an exception here. We don't need to meet these efficacy standards if the HRV or ERV is interlocked with an air handler, and that air handler has an ECM motor. Other than that, we need to meet these minimum efficacy standards, CFM per watt, for the fans based on the application.
So for the commercial energy code, the ventilation requirements are the only requirements are that you meet standard ASHRAE 62.1 version 2016. 62.1 is for commercial buildings and 62.2 is for the residential buildings that Matt mentioned earlier. This is the same as what was required in the previous version of the code. They just used the 2013 version of 62.1. That's been updated to 2016. I've got a link here for where you could access that standard. The biggest change in ASHRAE 62.1 2016 versus the previous version is that mechanical ventilation is now required for all new commercial buildings. It does not have a provision for natural ventilation anymore. So that is one thing to keep in mind, is that mechanical ventilation will be required for all new buildings on the 2020 energy code. Next slide.
Okay, that's an important change to note.
Yep. Also on the ventilation side, so on the commercial code where demand control ventilation will be required, that's CO2 based demand control ventilation. Any space that's larger than 500 square feet and has a occupant load of 25 people per 1,000 square feet or larger, and is served by one of these types of systems, the airside economizer system with a damper that can auto modulate, the outdoor air damper, and the design airflow rate is 3,000 CFM or more. If you meet those requirements, then demand control ventilation is required for that space. As always, there's a couple exceptions listed here. If you've got an energy recovery ventilation system in that space, then you're not required by code to also do demand control ventilation. That is something that you can put in for additional energy savings if needed. If there's no direct digital controls system for that space, you do not need to do demand control ventilation. It'd be hard to control that way. If the supply air less the makeup air is less than 1,200 CFM, then it's a small enough system that you don't need demand control ventilation. And if the ventilation is just for process applications, not occupants, then you do not need demand control ventilation. Next slide. A new addition to the commercial code is for parking garage ventilation. It's for enclosed parking garages, and that is applicable for garages with either no or 40% of the garage having permanent openings within it. And you must follow the Vermont Fire and Building Safety Code ventilation rates, which states that you need to have a continuous ventilation rate of 0.05 CFM per square foot at all times, and the system must have the capacity to ramp up to 0.75 CFM per square foot of garage space, and that is that system must be staged between the continuous and design rate based on carbon monoxide sensors throughout the garage. Each sensor can only cover 7,500 square feet, and there's some other listings in there about how this system must stage or continuously modulate based on carbon monoxide levels in the garage. And if any of the sensors fail in the garage, the failure default is just to go to 100% exhaust in that area. Hold on here. For energy recovery systems in the commercial code, the language has changed somewhat from fan systems to air systems, which I'll describe what a fan system is later in this presentation. So that is a somewhat important distinction with the new version of the code. Besides that, the requirements are mostly the same for energy recovery systems. The effectiveness of the system is still at 50%, and there are mostly the same exceptions. If a space is heated to less than 60 degrees or it's operating less than 20 hours per week, you do not need energy recovery. Also, if you are exhausting toxic or flammable fumes and dusts from a space, you do not need energy recovery. Or kitchen hoods that are removing really heavily grease-laden air do not need to have them. A new exception that's been added is that if 60% or more of the heating energy is provided from site recovered energy, then you do not need to have an energy recovery system. Next slide. So this is I copied and pasted the table in the middle there from the code. And what's important to note here is that energy recovery is required for air systems that are operating 3,000 hours or more per year. If that's the case, then you would look at this table to try to see whether or not you need to put it in with the code. And it's a little complicated looking through this. Even I get I look at it all the time and I still get confused with it. So I'll go through a quick example here to try to help make sense of this table and how I read through it. So the example I'll use is a rooftop unit, a pretty large one that has 10,000 CFM of supply air, and it's operating 4,000 hours per year. So based on that, it's over 3,000. So that means that you would need to then look at the table and the outdoor air part of the example is 3,000 CFM for this. So the percentage of outdoor air, which is the top level of the table for this unit, is 3,000 over 10,000. So that's 30%. So what you would do is go to the third column where it states greater than or equal to 30% and less than 40% outdoor air at design. And then you would just go down the table there to show what the design supply airflow rate would be or must be in order to need an energy recovery system. And that states greater than or equal to 5,500 CFM. And as I note here, this is a 10,000 CFM supply unit, which is greater than 5,500. So based on all that, this rooftop unit would need energy recovery serving it. So hopefully that makes a little bit more sense how to look at the table. Kitchen exhaust demand control ventilation are the same requirements as the 2015 Energy Code. For kitchen exhaust systems greater than 5,000 CFM, you would need to do one of these three types of ventilation strategies. The first is that 50% of the replacement air for the kitchen must be transfer air that would have been exhausted from the building otherwise. One of the more common strategies is number 2 here, which is a demand control ventilation system, where the hood can modulate its speed based on the temperature of the exhaust air going through it. So you would need to have this demand control ventilation controlling 75% of the exhaust air in your kitchen. You add up all the exhaust rates of all the kitchen hoods together, and the system must be able to reduce the flow down to 50% or lower. And the last strategy here is a UL listed energy recovery system within the hood itself, and it needs to be 40% effectiveness and similarly be installed on at least 50% of the kitchen exhaust air. So not every hood, but at least 50% of the volume of air. Yep. Next slide.
For RVs, there is in section 305 mandatory combustion safety requirements, and these are not new. This applies to new construction, new systems, and renovations. And those buildings, those construction types are going to be considered unusually tight per NFPA 54 and NFPA 31. So we're considering renovations as unusually tight as well. So natural draft burning appliances shall be provided with combustion and dilution air. Exception is if you have a direct vent sealed combustion system, but then that's not natural draft, so it's sort of a little counterintuitive there. We can't take combustion air from a crawl space. We can't use unvented room heaters. And we can't, and solid fuel appliances like wood stoves and fireplaces have to have gasketed doors and outdoor combustion air. And there's more requirements there for the closure mechanisms and things like that. So be sure you're up to snuff on this stuff.
Now we'll go through some more of the additional building mechanical system requirements for the commercial code, which would be in section C403. This is an overview of some of the changes that I'll go through. The electric resistance backup heating with cold climate heat pumps, the equipment performance increases of individual pieces of equipment, energy recovery systems, I've already discussed. We've got some economizer upgrades and parking garage ventilation I went through, and VFDs on fan systems. Next slide. So a new pretty important addition to this 2020 code is that overall, same as the old code, electric resistance is prohibited from commercial buildings. So that's still the same, but there's a couple new exceptions in here. The first being multifamily buildings that are meeting pretty stringent heat load requirements can have electric resistance backup heating. And those are multifamily buildings with less than or equal to 6 BTU per hour per square foot heating load at design temperature. Those buildings could use electric resistance heating. And then similarly, any building using cold climate heat pumps that can meet the full heating load requirements at 5 degrees outdoor air temperature, and you also need to have a blower door test on that building that tests tighter than what the standard test level is. So it must test a 0.2 CFM 75 per square foot. The standard new code rating is 0.3 CFM 75 per square foot. And also new to this code with the testing procedure is that it's at 75 pascals depressurization as opposed to 50 pascals in the previous code, and it is a 6-sided surface area calculation, not just the 5-sided. So the basement and below grade walls are now included in the surface area calculation. So if you meet those different requirements, then some electric resistance heating is allowed. For both of those, I will note that if it's in Burlington, you need to get pre-approval from Burlington Electric Department before installing those systems.
Charlie, is the idea here that like for bullet point number 2 with heat pumps, like the electric resistance heat would be perhaps a backup heating system?
Yes,
heat pump?
Below 5, yes. So the heat pump must operate down to 5 degrees Fahrenheit and meet the full load of the building. After that, below that temperature, that's when electric resistance heating could be used in conjunction or on its own to heat the building. And that's why there's a more stringent air leakage rate there to make sure that the load of the building is as low as possible.
So it'd be good to note for an HVAC contractor, if you're being asked to install electric resistance backup heat on a cold climate heat pump, that you know that they're planning to build this envelope as a very tight envelope.
Yes.
Which is a little strange because it's outside of the scope of work for the HVAC contractor to build a tight envelope, but it's where we have to sort of integrate our teams here.
For sure. So then in the commercial code, there are some requirements for mechanical commissioning. I'll go through these later on in the presentation. That's section C407 of the code. And there is also a requirement in there that HVAC equipment can only be upsized 10% based on what is designed. So that's something to take in mind that's new for this version of the code. Next slide. For the performance of the individual pieces of equipment, I don't have them here, but there's a bunch of tables for all the different types of equipment that you could have in a building. There are actually very few changes from the 2015 commercial energy code. That's mostly the same. So air conditioners and condensing units, there were no changes. Heat pumps, there's a small increase in the seasonal heating performance in the smallest capacity heat pumps. Water chilling packages, there's no change. And for VRF systems, the air-cooled VRF has slightly higher heating and cooling efficiencies, water source VRFs, a seasonal IEER efficiency has been added, and ground and water source VRFs are the same efficiencies as 2015. For part load controls in commercial buildings, any water or hydronic system greater than 300,000 BTU per hour shall have supply water temperature adjustment on both the heating and cooling side. And it must be at least 25% reset of the supply water temperature. And that's based on building load or outdoor temperatures. You have to be able to vary the pump flow for any hydronic pumps 2 horsepower or greater. The old requirement was 5 horsepower or more, so that horsepower limit has been reduced. So it'll be applicable to more pumps, and you have to be able to reduce the flow of that pump at least 50%. And this entire requirement for hydronic systems greater than 300,000 BTU, that is an update from the old code, which said hydronic systems 500,000 BTUs or greater shall follow these. So the capacity limit and the size of the horsepower pumps has been reduced for the 2020 code. Next slide. So as I mentioned earlier, this is not in the code, but it's a definition that can be important for certain mechanical systems in a building. It's a fan system, and the fan system is actually the group of components that where the heating and cooling is actually being transferred to the air and then distributed throughout the building. So some examples here, some smaller, single zone units. If you've got a VRF water source heat pump, it's going to be the indoor units that are actually the fan system. And similarly, a fan coil unit or a small rooftop unit that's just serving one zone, that is the fan system, where the heat and cooling coils are interacting with the incoming supply air. And if you've got larger units like a big air handler or rooftop unit that's up on the top of the building, and the heating and cooling coils are up there, and then it's distributed throughout the building, those are the actual fan systems. So the reason that matters is for both economizers, energy recovery, and a couple other systems, they call out requirements for fan systems. And so that's an important definition to keep in mind. Next slide. So now, speaking of economizers, economizers are required on chilled water systems with capacities. Once you subtract the economizer's capacity greater than 1,320,000 BTU per hour for a water-cooled system, and 1,720,000 BTU per hour for an air-cooled or district chilled water system. And it's also required on fan systems, as I mentioned previously, fan systems with a cooling capacity greater than or equal to 54,000 BTU per hour on buildings that are not in the group R occupancy type. That's a residential commercial building, so like multifamily or hotels and motels. And anything that's in the group R occupancy, the fan system would have to be greater than 270,000 BTU per hour to require an economizer. And the number of exceptions for this requirement have been reduced from the 2015 code. I've got a couple of them listed here, just spaces that need to be humidified above 35 Fahrenheit dew point, systems operating less than 20 hours per week, or if you have heat recovery ventilation in or tied in with that system, then it does not need an economizer. Next slide. The controls for an economizer, you need to be able to have both integrated mechanical cooling and partial economizing at the same time. So the outdoor air damper should be able to be 100% open if needed down till 45 degrees Fahrenheit. Below that, there's some freezing issues that you would worry about, so you might close the outdoor air damper a bit below that temperature. And if you've got direct expansion cooling units, if they are greater than 75,000 BTU per hour, you need to have at least 3 stages of cooling, and greater than 240,000 BTU per hour, they must have at least 4 stages of cooling. And that's an exception to that is if you have a constant speed compressor and then an additional variable displacement compressor or compressors that could modulate the load as needed. The high limit temperature shutoff for an economizer has been decreased from 75 degrees down to 70 degrees Fahrenheit. So that'll increase the range that you could use them throughout the year. And the economizers also need to have fault detection diagnostic controls. Next slide. Airflow control for commercial buildings. So when do you need to vary the airflow in a building? Any cooling system that is 2 tons or more needs to have variable air flow. And that has been reduced from 5.4 tons from the current 2015 code. So that'll be applicable on many more systems on commercial buildings. For direct expansion and chilled water units, you need to have at least 2 stages of fan speed control. The low speed needs to be at least 2/3 the maximum speed or 40% power draw of maximum speed. And for any non-direct expansion or chilled water units, it must be at least a 50% speed reduction in the fans or 30%, at least 30% power draw from maximum design. Next slide. For fan speed control, any fan system 2 horsepower or more needs to have a VFD on it. The requirement in the current code was 7.5 horsepower. So again, that horsepower rating's been reduced. So VFDs will be required on many more fan systems. Heat rejection devices need to reduce their fan speed to at least 50% design airflow or 30% fan design wattage. I believe that is the same requirement as the previous code, but I'm just noting that again. Next slide. Duct insulation levels are the same as the 2015 code. That hasn't changed. I do not have them in here, but they'll be the same. For pipe insulation, it is required, whether it's hot or cold water that's being supplied through the pipes, for any temperatures outside of the temperature range 60 degrees Fahrenheit and 85 Fahrenheit. And this is an update. The old limit was 60 degrees to 150 degrees, 115 degrees. Within there, you did not need pipe insulation. They've brought that high limit down a bit. So even just slightly warm water will need some amount of pipe insulation. Next slide.
I wanted to bring this up in the Arby's code update. There's air barrier provisions in section 402, and where you may think air barrier provisions would have to do with the building contractor, not necessarily the mechanical contractor, some of the things in there do cross the lines here. So for example, recessed light fixtures have to be ICAT rated. All plumbing and wiring penetrations have to be sealed to the air barrier. Exterior walls adjacent to showers and tubs have to have a rigid, durable air barrier behind them. So yeah, if you're installing a tub on an outside wall and you don't see that air barrier, maybe it makes sense to call that out. Register boots that penetrate the thermal building envelope have to be sealed to either the drywall or the subfloor. So there are some provisions in the air barrier thing that HVAC contractors should be aware of. Section 403 in the residential code discusses systems. So it gives us requirements for all these different systems, including controls, ventilation, hot water systems. All the stuff that's discussed in section R403. 403.1 requires programmable thermostats, and there are some exceptions to that. I think if you have a radiant heating system, there's an exception for that. In 403.1.2, heat pumps cannot have integrated electric heat other than the defrost mechanism. So we don't really see that in cold climate heat pumps pretty much anyway, but just to note that that provision is in there. Our 403.2 boiler outdoor temp setbacks are mandatory for 1 or 2 pipe hot water systems. There's a lot of duct provisions. So the exceptions for these duct provisions are if the ducts are indoors or if they are ventilation ducts. But duct testing is required. There are provisions in both rough-in and post-construction testing. So the duct leakage testing, we have to provide a written report. The person doing the testing and writing the report has to be certified as either a BPI heating professional, air conditioning or a heat pump professional, a home energy rater, or the Vermont Department of Public Service approved duct leakage tester. So again, you have to file the report with the authority having jurisdiction. Also have to file it to the DPS at the state and along with the RB certificate. So the rough-in test, if you want to test your ducts at rough-in, we need 3 CFM, the limit is 3 CFM 25 per 100 square feet of conditioned floor area. A post-construction test would be 4 CFM 25 per 100 square feet of conditioned floor area. Also, there's provisions that building cavities shall not be used as ducts or plenums. I think in prior versions, it was okay to use building cavities as a return plenum, but that's no longer the case. So ducts buried in insulation have to have duct insulation greater than R8. And the insulation on top of them needs to be not less than R40. Ducts in conditioned space completely within the air barrier and within the thermal barrier. So they're defining what conditioned space means. Buried ducts as per 403.3.6 and the air handler has to be inside the envelope. The duct leakage has to be less than 1.5 CFM 25 per 100 square feet of conditioned floor area. And the ducts have to be buried to the insulation value. So that means if your insulation in the attic is R60, the ducts need R60 on top of them. So there's some water heating provisions in R403. Here, the hot water pipe insulation is required on pipes with fluids containing temperatures above 105 degrees Fahrenheit. That needs to be an R3 minimum pipe insulation. Surface hot water circulation systems, the thermal siphon systems are prohibited. Demand control only, and the automatic shutoff at 104 degrees Fahrenheit. So those are the provisions for recirculating systems. Hot water pipe insulation is required on pipes 3/4 inches and larger. Pipes that serve more than one unit are located outside conditioned space. It's required between the water heater and a manifold. It's required under a slab floor, buried piping, for instance, buried in an attic insulation, and on recirculating loops. Drain water heat recovery is not required, but if it's installed, they have some pressure drop stipulations here. So a drain water heat recovery unit serving 1 or 2 showers can drop as much as 3 psi from the supply pressure, and serving 3 or more showers can only drop 2 psi from the supply water pressure.
So the commercial requirements for service water heating are in section C 404. The maximum size of a electric water heater has been increased from 5 kilowatts up to 7.5 kilowatts. Some exceptions to that are any instant electric water heaters that are serving emergency shower or eye wash stations. Those can be larger. Or hybrid heat pump water heaters do not need a do not have a kW limit. If you meet all of these requirements, you need to have at least 60% of the hot water demand coming from the heat pump function of the water heater alone. Any shower heads in a building must be less than 2 gallons per minute, and any dishwashing equipment in the building must be ENERGY STAR rated. There's a table in the code with all the hot water performance requirements. Some new equipment that's been added in there are 3-foot tall tabletop cabinet sized water heaters and grid enabled water heaters. And those grid enabled heaters must have a 75-gallon storage tank tied to them, and they must have been manufactured after April 16th of 2015. A heat pump water heater performance requirement has been added to the code, and there have been slight increases in efficiency for gas and oil storage heaters and instant gas water heaters. For high input water heating systems, pretty big systems in commercial buildings, for gas fired equipment, the individual equipment size thermal efficiency has been increased from 90 up to 92. And if you've got multiple pieces of equipment all serving the hot water demands of a building, the weighted average of the capacity of all those units combined must be 92% efficient. So you could have some units lower, some higher, but based on the capacity, averaged altogether must be also equal to 92%. There's some exceptions to this. You don't need to meet those efficiency requirements if at least 25% of the hot water demand annually comes from on-site renewables, or for if you've got individual dwelling units that have their own individual hot water heaters, and those heaters are less than 100,000 BTU per hour in size, you don't need to include them in the larger building scale high input water heating systems. You don't need to include those in the calculation up above. Next slide. For circulation pumps on the hot water system, you need to have either a time switch that turns the pump off when there's no hot water required in the building, usually based on occupancy. If it's say a business or a office hour type of building, you'd turn the pumps off when no one's in there, or have a modulating pump set to a aquastat to control the pump based on the pump return water temperature. So if there's not a lot of hot water demand, then the pump will slow down, or if there's a lot of hot water being used, then the pump's going to speed up to circulate more water. And there is an exception here for healthcare facilities, where Legionella's disease could be an issue in having sort of stagnant water not circulating through the building. You need to meet the requirements of ASHRAE standard 188 in healthcare facilities. In this version of the code, the maximum allowable pipe length section has been removed completely. This is pretty good news. I know there was a lot of confusion in the 2015 commercial code with the allowable volume and length of the hot water piping that you could have for the hot water supply. It was pretty hard to meet those requirements, so that has just been removed from this version of the code altogether.
So RB's section 4037 puts down some guidelines on equipment sizing and efficiency, and this is mandatory. So all building loads have to be calculated using ACCA Manual J or an approved equivalent. Heating and cooling equipment must be sized according to Manual S. The new heating and cooling equipment has to have efficiency greater to or equal than minimum federal standard for climate zone 6. So minimum federal standard is not that high. That shouldn't be too hard to hit, but you do have to size it in accordance with Manual S, and your heating loads have to be calculated according to Manual J. Systems serving multiple dwellings have to comply with 403 and C404 of CB's. So this would be like in a multifamily system. We're using CB's code for that. There's a snow melt and ice control stipulation. So for pavement greater than 45 degrees during precipitation and the ambient greater than 40 degrees, we need to have a control that will shut off snow melt and ice control. There's pools and spas. The heater, the on-off heater has to be accessible and less than 3 feet away from the heater. We have to design residential pool and spa heaters in accordance with APSP 15. The on-off switch cannot adjust the temperature. No pilot lights on the gas heaters. Also, the time switch for pumps and heaters shall be installed. And R12 insulated covers for heated pools and spas are required. So there's also a stipulation around electric resistance heating equipment. So heat pumps having supplementary electric resistance heat, so that's not the integrated electric resistance heat we saw before, shall be certified cold climate heat pumps and shall have controls that, except during defrost, prevent electric heat from coming on when the heat pump can meet the load. So building heating with electric resistance heat is prohibited, and there are some exceptions. So we can replace existing electric resistance units. So in limited areas where it's cost prohibitive or impractical, and these are laid out as sometimes stairwells, bathrooms, things like that. Cold climate heat pump, primary provided controls prevent use above 5 degrees. So if we have a building that's less than 2.0 ACH 50 and we have a cold climate heat pump as the primary heating source, we need to install controls that will prevent the use of the electric backup heat above 5 degrees Fahrenheit outdoor air temperature. And multifamily buildings less than 6 BTUs per hour per square foot at design temp. I think Charlie pointed that out earlier. There's an exception for the electric resistance prohibition for those units as well. So replacement, did we just go through all this?
Yes.
Yeah. Interesting. So buildings served by Burlington Electric Department have to get prior approval, and that's the same as in the CV's code. So here are some air leakage requirements. for Arby's, the code is 3 ACH 50, and that includes the volume for the conditioned basements. For CB's, it's 0.3 CFM 75 per square foot, and that includes all 6 sides of the building enclosure. If you're wondering how to calculate that, use the entire enclosure. So Arby's Chapter 5 applies to existing buildings. 501.1.1 stipulates that alterations, additions, or repairs to an existing building system must comply with those sections of our Chapter 5, our 502, 503, and 504. Unaltered portions of the building are not required to comply with the code. Connections or repairs to or maintenance of existing mechanical systems don't constitute an alteration to the system and therefore don't need to comply with the code. And again, we're talking about additions, alterations, repairs, or change of occupancy or use. That triggers a code in an existing building. So for additions, new heating and cooling and duct systems that are part of the addition shall comply with the code. Connections or repairs to maintenance of an existing system do not need to comply with the code. There's an exception where ducts from an existing heating or cooling system are extended to an addition. The ducts with less than 40 linear feet in an unconditioned space are not required to be tested. They are required to be sealed and insulated as per the code, but they don't need to be tested. And this same language for the heating and cooling systems applies in R503, which talks about alterations to a building. So it's the same whether it's an addition or an alteration. And new service hot water systems that are part of the additions shall comply with the new code. And again, connections or repairs to an existing system don't need to comply with the code.
For the commercial code, the relevant HVAC portion in the additions, alterations, and repairs is that for alterations, if you're you do not need to meet the code for the replacement of existing electric resistance units. That's been added to the 2020 code. That was not mentioned in the previous version. So those alterations do not need to put in a different mechanical system. You can just swap out the electric resistance unit for a newer one. And then on the commercial code, once you finish all the requirements for the code, there's this section C406, additional efficiency package options. There are 10 of them, and each one has a different points allocated to them. Let's go to the next slide. So for a new building, you need to get 6 credits. And that's just for any existing building does not need to meet these requirements, just new buildings. And if it's a building with tenant spaces, only 3 of these, you only need to get 3 credits. So there are these different building occupancy types listed here. We've got R1, which is hotels, motels, R2, apartments and dorms. B is office buildings. E are K through 12 schools, and M are merchandise sales areas. So you would use, and then there's also an all others category. If the building has 65% or more that's listed in one of these categories, R1, R2, B, E, and M, you would use that. Otherwise, you'd use the other group. So out of the 10 credits, I'll go through the ones that are applicable to HVAC systems. So the first credit is for more efficient HVAC performance, and you would need to have 15% more efficient HVAC equipment for all of your equipment that is listed in the 12 performance tables of the code, including heat pumps, boilers, chillers, any of that equipment. And 90% of your equipment in the building must be the types of equipment that are listed in those tables. So if you hit that requirement, as you can see in the chart here, you find your building occupancy type, and then down below that are the number of credits that you could get for doing that. So you need to get 6 credits. So I mean the mercantile, the sales type building, you could get all your credits just for doing this one type of additional efficiency package. I will note that if there's any standalone supply and exhaust fans that are bigger than 1 horsepower, they need to meet a certain fan efficiency grade of 71, which is 1 higher than the baseline of 70 that's required in the code. Next slide. This isn't necessarily tied to HVAC, but I thought it was pretty good to share. The 4th credit is for on-site renewable energy. So if you install an on-site renewable energy system based on the table on the right, the energy per square foot of building type. So you've got all those building types, and you've got kBTU per year or kilowatt hours per year. It's the same number, just converted. The units have been converted, so you could either put all your building energy into kBTU or kilowatt hours, and then decide what how large of a system you need to design. And again, the renewable energy sources can be solar, wind waves, landfill gas or biogas. Biomass wood heat does count as on-site renewable energy in this code, or geothermal heat. Next slide. You can install a dedicated outdoor air system in your building. That's always 100% outdoor air being supplied to the building at all times. You must be serving 90% of the conditioned floor area with this dedicated outdoor air system, and you have to follow the requirements of ASHRAE 62.1 2016, and that includes supply air temperature reset of the air coming from that dedicated outdoor air system based on the building loads or outdoor air temperature. Next slide. The 6th credit that you could do is for high efficiency service water heating. The first thing I want to point out here is that only certain building occupancy types are applicable, or can't even use this requirement. Those are the types of buildings that have higher water usages. So R1 and R2, so that's hotels, motels, and apartments and dorms. And so then in the middle, businesses, education, and mercantile building types are not applicable to this requirement. And at the end, group I, which are industrial types of buildings, can use this credit. So there are 3 different options, and I've got 3 different tables listed here for the number of points you can get. The first option is a load fraction option, where 60% of the hot water to the building would be provided by waste heat recovery or a renewable energy hot water heating system. Then you would get the points allocated to the right there. The second option is high performance hot water equipment, and that would be increasing the efficiency to 95% for all of the equipment in the building. And then you could get those points allocated to the right. The third option is heat pump water heating equipment, where you would need to have an increased coefficient of performance of 3 for the equipment. And you cannot draw conditioned building air into those heat pumps unless it is air that was otherwise going to be exhausted from from the building to the outside. That's the only time you can use conditioned air within the building. And I think our little icon's in the way at the bottom, but you would get 5 points for R1, 5 points for R2, and 2 points for an industrial group there. Next slide. Oh, that's you, Matt.
So we did talk earlier about the package and points. I thought it maybe was relevant to discuss that because some of the points that you can get in addition to what you get for the package, some of the points you can get do have to deal with HVAC. So look at this slide, for example, and we look at package 1, the standard package. That's all of the things you would need to do to the home. So and if you look at the duct leakage, it would need to be inside the thermal boundary. There is only one package that allows ducts outside the thermal boundary, and that would be package 3, the thick wall package. So if you look at that column under package 3 and chase it down to the mechanicals row, you can see 4 CFM 25 per 100 square feet of conditioned floor area, and that would be tested at completion. There's air leakage test and that sort of thing. So in addition to doing all the package 3 requirements here, the building would also need to gain a certain number of points based on the size of the building. So if it was a less than 2,000 square foot building, or if it was a multifamily building with a dwelling size less than 2,000 square feet, or 2,000 square foot residential building needs 5 points. Anything larger than 4,000 needs 10 points, and it vary in between. So what are those points? Here's the points table for the base code. So we can see there's points for the envelope for air leakage and ventilation. There's points for heating and cooling systems, which is where, and for water systems, and this is where the HVAC stuff comes in. So if we're building, for example, under the air leakage and ventilation section, if we're building a very tight home and using balanced ventilation with ECM fans, they're specifying a sensible recovery efficiency for the HRV and a different sensible recovery efficiency for the ERV. So that's worthy of your note here. Under the heating system, we have advanced heating and cooling systems and basic heating and cooling systems. So just familiarity with the points. This may be why a builder is specifying a certain system, or he may give you a performance specification for a certain system, and this would be why, because they're looking to get the right amount of points for their building. So that's for the base code. Stretch code has a similar thing, but the packages are different, and the number of points are higher. So here we can look at packages. There is no stretch code package that allows allows duct systems outside the thermal boundary. So if you're in South Burlington or another town that's adopted stretch code, or the building's being built in a development that was subject to Act 250 review, they're going to need to meet stretch code, which means ducts inside, and higher amounts of points. And here are the point tables for stretch code. Again, we're seeing air leakage with high efficiency ventilation. We're seeing points for heating and cooling. We're seeing points for drain water heat recovery, things like that. Again, just to make you familiar that there's this point system, and some of the points are given for higher efficiency mechanical systems.
So one of the last system chapters of the Commercial Energy Code is for commissioning systems, which is section C407. Next slide. So you need the commissioning agent needs to have experience with at least 3 previous projects that are at least 20,000 square feet or more. The commissioning agent also needs to be a third-party entity that cannot be an employee of any of these listed teams, the design team, construction team, or an employee of the owner or developer of that building. Next slide.
Is this a new provision, Charlie?
I believe, yes, some of these have, or at least the experience part has been added. The third party is not a change. There are some more changes to this section of commissioning for when you know which buildings need to be commissioned or not. So the provision from the current code, the 2015 energy code, was any building 50,000 square feet or larger must be commissioned. That square footage requirement has been removed from this portion of the code, and instead it is mechanical heating and cooling size requirements that trigger whether commissioning is required. So for a cooling system that is greater than 480,000 BTU per hour, that's 140 kilowatts. Any cooling system larger than that would need to be commissioned. And if the both space heating and service water, domestic hot water systems combined capacity, both of those, is 600,000 BTU per hour or more, then you'll need to commission that system. So that is like, both of those are going to make it a lot more common for buildings to require commissioning for the 2020 commercial code. Next slide. And these are just some of the requirements that are laid out for what you need from building commissioning. You've got to have a commissioning plan, systems adjusting and balancing plan for both your air and hydronic systems on the HVAC side, functional performance testing for your HVAC equipment, any of the controls tied to that equipment, and your economizers as well. Lighting's included in this as well, the fixtures and controls. You got to have a finalized commissioning report where you document certain aspects, and also include that balancing report from earlier, any notes to the construction drawings that have been made from the commissioning agent, and an operations and maintenance report. All of this will be provided to the owner after it's been completed.
All right, I think that is all the content that we have prepared. I don't know if there are any questions, or if you want to chime in if there were any in the chat. I was not following the chat.
No questions in the chat. So
Great.
we could probably wrap things up. I just wanted to remind folks to keep an eye out for future code trainings. You can find them posted on the Efficiency Vermont website at efficiencyvermont.com/events. And I'll share that in the chat. And in addition, for code support, if you have any code questions or are looking for assistance, call the Energy Code Assistance Center toll free at 855-887-0673. So I'll add that number and the information about the link to the trainings on our website. You can find this training and other trainings posted on our website as well. So thank you again for joining this webinar. We hope you found this session to be a helpful overview of the code changes for HVAC portions of the Vermont RBs and CBs. And just a reminder that this webinar is available for EEN credit. So if you're watching this as a webinar, be sure to keep an eye out for information on how to make sure you've received credit. So thanks again. And if there aren't any additional comments, Matt and Charlie, we can wrap it up.
All right.
Okay, thanks everybody.
Thanks.
Thank you.